Okay, so before we get started, I hope that you will have a calculator out with you because we're going to need it to do some of these problems that are on pages 186 through 188. And so it would be good to have them out and ready to go. Okay, so there are two formulas that we're going to be using. So again, we've been talking about exponential functions. Again, those are functions that are in the form of y equals b to the x, but again, there can be transformations to it. So most often it's written a times b to the x, where b is the base. And again, the one that we're most familiar with is we've been using 1/2 to the x, but there are others. Again, when we first started doing this, we played around with what happens when we change the base. And then for a while we said what happens if we stick with the same base but change things around it, like subtract things or add things or multiply by a negative or multiply by a 5 or something. And so we've got this idea of exponential growth looking like this and exponential decay looking like this. And again, we said decay happened when when the base was between 0 and 1. And we said growth happened when the base was bigger than 1. All right. So there are plenty of formulas in math that we use that have applications to your everyday life. Maybe not your everyday life yet, but soon they will. And two of them are the first formula, which is on growth for interest, usually. And then the second one is for half-life. And this would be seen frequently in science class, especially when you're talking about radioactive material and its half-life. So how many years does it take before half of that substance has decayed? All right, so we'll look at that in another video, but for right now we're going to really focus our attention on this formula right here. All right, so there are different parts of this formula. So, and again, I wrote a list right here for you so you can, if you ever forget, you can look back on it. So the first thing is this value P. P stands for principal amount. And when you're talking about interest, again, we talked about interest in pre-algebra a bit if you were here with us. And we said the principal is just the initial amount. So let's say you deposit money into a savings account or an IRA account. The principal would be how much you have put in there to begin with. And then the R is your rate of interest. All right, so maybe you're getting 10% interest. We wouldn't write it as 10% interest. We would write it as 0.1. So whatever to get rid of that percent, we divide by 100, and that is the form we use. So when I say as a decimal, again, if it has a decimal, like let's say it's 1.7%, it doesn't mean 1.7. It means divide it by 100, so that we would get 0.017. Right? The number of years is the amount is borrowed for. That's called t, and that is up in the position of the exponent. There's also a second thing up there, and that is n. That's the number of times that the interest is compounded per year. Again, we talked about this in pre-algebra when we talked about interest rates, but for those of you that weren't there, interest, when you earn interest on your interest, that's called compounding. So for example, let's say you put $100 in and then you earn interest, and at the end of the month you then have, or let's say at the end of a year you have $106. And then, but you don't take that $6 out and keep it for yourself. You leave it in there, and then you're now earning interest on $106 instead of just $100. So compounding is when you're earning interest on your interest. All right, and then A is the amount of money that is accumulated after n years, including interest. So this is essentially your ending amount. All right, so this is the beginning amount. All right, now notice that n shows up in two different places. So for example, the number of times the interest is compounded in a year, your interest might be compounded daily. That might be one, daily. Let's try that again. Daily, and then n would be 365. All right, or suppose it was weekly, then n would be 52. Or monthly, and that would be n equals 12. Right, so different amounts right there. And so what it's saying is I'm going to take the amount of money that I put in there, and I'm going to figure out how much interest I give during every period. All right, so if it's daily, I'm going to take that rate, like let's say it's 10%. All right, and I'm going to take that 10% and I'm going to split it up over 365 days, because I'm not getting 10% every day. I'm getting one 365th of that every day. All right, so we would take our rate, we would split it up into however many times it's being applied. So 365 if it's daily, 52 if it's weekly, 12 if it's monthly, right? And so I'm going to see what the actual interest rate is based on how many times it's compounded. Now again, the principal is the amount I'm starting with, but I'm not just getting the interest rate on the principal. I also get to keep the principal that was in there. All right, so if you think of that if I think about when you do tax on something, that if I buy something, let's say for $20 and I have to find the tax, I could do that. But if I want to find out how much my total purchase is, I would do 20 times 1.06. The 1 is I pay 100% of the $20 item I'm purchasing, and I also pay 6% of that. All right, so that's the function of that 1, is that it says I keep all of my I keep all of my principal plus I add this interest onto it. All right, so that's why we have the 1 in there. And then again, the time is how long, how many years am I doing this? And then the n is how many times during the t years, let's say it's 5 years, how many times am I applying interest to it? All right, so this n splits up the rate so that we get a much smaller rate, but we get it more often. And then this takes the time, and it says how many of those, again, if it was monthly, then I would take, and let's say I had 5 years, then 60 times interest would be applied. 5 years times 12 times if I was doing monthly. Or if I was doing 5 years and I was doing weekly, then I would do those 5 years and 52 times for every one of those 5 years, because it would be applied weekly. So that's the purpose of that, right? So that we end with, I take my original principal, I keep my principal, I add interest onto it, and this tells me how many times I do that. Okay, if that was a little bit much, maybe pause, go back and start again just to listen to it, because it is a lot right there, but hopefully you'll see how all this plays in. All right, so if you invest $25,000 in an account that gets 12% annual interest rate compounded quarterly, how much would you have in 12 years? All right, so again, let's read it one more time. If you invest $25,000 in an account that gets 12% annual interest compounded quarterly, I'm going to underline some of these things that are important. $25,000, 12% interest, that is compounded quarterly. How much will you have in 10 years? All right, so let's just write down these letters, P, R, T, A, and N, and we're just going to say if we know them and if we don't know them. All right, so do we know the principal or the initial amount that we have? All right, hopefully you said yes. I know that I put in $25,000. Okay, so again, it's amount that you borrow or deposit. I guess invest would be another way to say that. All right, that would be like deposit. All right, do I know the interest rate? All right, the annual rate of interest. Yes, it's 12%. And again, we don't want to write it with the percent. We write it as 0.12. All right, do I know the number of years that the amount is deposited or borrowed for? Yes, it's 10 years. All right, do I know the amount of money that's accumulated after that number of years? And the answer is no. So this is just A. All right, and then finally, well, that should be T years. I don't know why it says N years, T years. All right, and then do I know how often it's compounded? And then yes, it's quarterly. That means 4 times in the year it's compounded. All right, so take a second before you start these problems to write that down, all the things that you know. You should know, of the 5 things, you should know 4 of them. You can't not know, you can't know any less than, let's see that, you can't have more than 1 unknown. So you need to know 4 of them. All right, so let's write our formula down. A equals P times 1 plus R over N to the NT. All right, so again, I don't know A, so I'm going to leave that blank. But I do know P, that's 25,000. And then 1 plus the rate, which is 0.12, over the number of times that we receive that, so 4 times. So again, the rate is not really 0.12 every single time we get applied interest, because it's being split up over 4 times. So really each time we're getting interest, we're getting 3% of that, not 12%, but we're going to apply it 4 times. All right, and then to the N, which is 4 times T, which is 10. All right, now this part might be a little bit tricky depending on the calculator you have. So if it's at all convenient to multiply these 2 together first before you plug into the calculator, I would do that. So I'm going to change this to 40 because it was easy. There are other times where it might not be easy, in which case I would just say, when you enter this into your calculator and you have to use the caret key for the exponent, make sure you put that 4 times 10 or whatever it is in parentheses. Don't just do caret 4 times 10, because it's going to do order of operations and it'll do exponent first and then times 10. You need it to do that whole exponent, so just be careful with that part. All right, I'll leave that there for a second. Okay, so let's get the calculators out. And we're just going to enter that in exactly as we have it. All right, so I'm going to type in 25,000 times, I'm just going to do parentheses, 1 plus 0.12 divided by 4, end parentheses, exponent or caret, all right, and then I'm going to put 40. All right, that tells us, wow, that's a good amount of money. $81,550, and 94 cents is how much we are going to end with. If we started with $25,000, earned 12% interest. That's a crazy, crazy amount of interest. I mean, I know interest is high right now, but even 12% is insane. So this is not realistic. But if it were that high, then after 10 years of compounding quarterly, this is how much money you would have. Now, again, the flip side of this is if you borrow money, if you borrow this, like let's say you want to buy a really fancy car, and you buy that and you have to pay 12% interest, that after those 10 years of buying that super fancy car, you've actually not spent $25,000 on that car. You've spent $81,000 on that car. So interest, if you're earning it, is wonderful, but if you're borrowing money, interest is your enemy. So just be really careful with that. Okay, let's take a look at the second problem here. Problem number 6. If you invested a penny on January 1st, 1776 at 10% interest compounded daily, how much would you have on January 1st, 2011? All right? Let's read it again. So January 1st, 1776, you're investing at a penny, so 1 cent, 10% interest, compounded daily. How much would you have on January 1st, 2011? All right, so first of all, let's find out what time is by figuring out how many years apart there are. So 2011 minus 1776, that's 5, that becomes 1, 9, 10, so 3, 235 years. Let me just double check that with my answer key. Yeah, 235 years. Okay, so we'll write down all our information. P-R-T-A-N. Okay, principal 0.01. Rate 10%. Again, don't write it as 10, write it, move the decimal over to get a decimal. T is 235 years. A, we don't know, that's what they're asking us to find. And N, how often is it compounded? 365 days. Pause for just a second, and I want you to think about how much you think that will be. All right, so again, there's no right or wrong answer. I just want you to make an estimate before you do this. All right, so pause and come back when you are ready. Okay, so hopefully you've come up with your guess. So I'm going to write the formula down. A equals P times 1 plus R over N to the NT. We don't know A. We do know the principal, 0.01. 1 plus the rate, again, decimal form, over the number of times that we're compounding, right, 365, to the N, right, again, 365 times 235. Right, now don't think because it's 365 that it's going to give us outrageously more, because remember, this is 10%, but divided by 365, that's a really small amount of interest that we're getting every time. So if I do that, 0.1 divided by 365, it's 2.74 times 10 to the negative 4. So 1, 2, 3, 4. So 0.00027 is the amount that we're getting added on there. So a very small amount, but let's see. All right, take the time to enter this into your calculator just to see if you're right. All right, I'm going to do it also. So 0.01 times 1 plus 0.1 divided by 365, close parentheses, exponent. Definitely need to do the opening parentheses here, 365 times 235. I hope you made a guess, because this is impressive. We end up with 160,148,364.3. $160,000, more than $160,000. Right, there's another point there. Interest and time are friends, right? So if you have a lot of time, you are going to get a lot of money. So start saving now, because it takes time to grow that big. Again, a penny is nothing. We throw them out all the time. But if you have a lot of time, you will get a lot of money from it. All right. So then you're going to turn to page 186. I mean, not 186, 189. Okay, so let's take a look at problem 10 again on page 188. How much would you need to invest to get $20,000 in 5 years at an annual interest rate of 8.5% compounded monthly? All right, so again, how much would you need to invest to get $20,000? Right, so it's asking how much do you need to invest. Right, again, that's what we were usually given. This is the P value. This is A, so it's asking us to end with $20,000. That's what A stands for. In 5 years at an annual interest rate of 8.5% compounded monthly. All right, again, we've got our 5 letters here. P, R, T, A, and N. Right, again, P stands for the principal, and again, it's saying how much would you need to invest. That means we don't know it, so that still stays P. R is our interest rate. Again, it's 8.5, so 8.5%, but we're going to write that as, move the decimal over twice to 0.085. The amount of time, it tells us, is 5. A is our ending amount. We actually do know that. In this case, it's 20,000. Right. N is the number of times that it's compounded. All right, and that's monthly. So in this case, N is going to be 12. Okay. So then let's set it up again. The formula is A equals P times 1 plus r over n to the nt power. All right, so now we're going to fill in $20,000 equals P times 1 plus 0.085 over n, kidding, over 12 to the 12 times 5. And again, that's easy for me to do in my head. I'm just going to replace it with 60, but if you do it like this, make sure you do 12 times 5 in parentheses. Okay, well, this is a little bit different because before we knew everything on this side. We could just enter it into the calculator, but now our variable is right here. So we're going to have to do things a little bit differently. So let's go ahead and just do this part right here and get a number for it. Right? So 20,000 equals P times, right, so again, you've got your calculators. You're going to do 1 plus 0.085 divided by 12 raised to the 60th power. Whoops, what did I do wrong? Oh, I didn't do a parentheses at the beginning, so let me go back there and insert a parentheses. If you have a graphing calculator and you don't know how to do that, that little INS right there is going to let you insert things. So I'm going to insert a parentheses. Just forgot to open a parentheses and only closed it. Okay, that tells us that this amount right here is 1.5273. Even just cutting this off early, like at 1.5, that will change the answer quite a bit. So usually you go out a few decimal places, maybe like 3 or 4. Right, so now this is unusual for us to see the variable in the front. Let me just write it one more time. 1.5273p. Right, so as unfortunate as that is, it's still just the coefficient of the p. And if we're trying to solve for this, then we divide both sides by that. It's 1.5273 and then 1.5273. These cancel out. Again, I'm going to go and do 20,000 divided by 1.5273, and I get $13,095, pretty much. All right, there's some extra stuff down here, but it rounds to that. All right, so I would need to invest $13,095, almost $13,100, so that I would end with $20,000 in 5 years. So let's try that just to check. If I start with this, A equals P times 1 plus R over N to the NT, and I put in that amount, 13,095 times 1 plus R, 0.085 over N, 12, to the 60th power. Do I get $20,000? Let's just double check that to make sure that we're right. So $13,095 times 1 plus 0.085 divided by 12 to the 60th power. Yep, I get that 20,000. All right, so that is the right amount. So we need to invest $13,095, and at the end of 5 years, at 8.5% interest compounded monthly, we will end up with $20,000. Okay, hope you feel all right with that. We will look at other situations where maybe we don't know how long that is. That's going to require us to know a little bit more about exponential functions and later on logarithmic functions. So we'll come back to that situation where we might not know how long t might be unknown to us, but we'll look at those later. All right, thanks. Bye.